Hello, in this video we will solve this problem, that is determine I of t in the below circuit. So we have two voltage source here, one is 50, another one is labeled as 50 u of t, where u of t denotes step function. So what does it mean? When t is less than 0, this voltage source will have 0 volt. So this voltage source will be active only after t greater than 0. So 50 u of t means when t is less than 0, this voltage source will have 0 volt. How to represent 0 volt? A short circuit. When t is greater than 0, this will have 50 volt. 50 into 1, so 50 volt. So 50 u of t means when t is less than 0, it is 0. T is greater than 0, it is 50. And you have two resistor, 2 ohm and 6 ohm, and you have one inductor, 3 Henry, and current passing through this inductor is I of t, and you are asked to determine the value of I of t. It's an example for driven RL circuit. Okay, so first one we will write for t less than 0. So circuit diagram we will draw. So for t less than 0, this 50 volt will be there, but this 50 u of t will not be active. How to denote an inactive voltage source? By 0 volt. 0 volt, how to represent 0 volt? It's a short circuit. And 2, 6 and inductor. So 2, 6 and 3, current passing through is I of t. And we have to draw t greater than 0. T greater than 0, this voltage will be active. So your circuit diagram will be, this is 50 volt and one more 50 volt will be active. It is minus and plus 50 volt. And you have one resistor, another resistor here, and another inductor is here. That is 3, 6 and 2. Current passing through this will be I of t. Okay, so this is t greater than 0. So step 1. Step 1. We have to find first initial current, that is I of 0 minus. So I of 0 minus, that is t less than 0. The circuit was kept for a long period of time, so it had already reached steady state. In the steady state, an inductor can be replaced by a short circuit. So we have a short circuit in parallel with the 6 ohm resistor. That is nothing but a short circuit. If 6 ohm is in parallel with 0 ohm, equivalent resistance will be 0 ohm. So though 6 ohm is present here, its presence is not felt by the circuit because you have a short circuit which is in parallel with that 6 ohm. So what is the current flowing through this inductor then? So you have 50 volt, 2 ohm resistor, and you have short circuit inductor, that is 3 Henry. This 6 ohm will not come into picture. So I of 0 minus will be total voltage, that is 50, by total resistor. Only 2 ohm resistor will appear. 6 ohm will not come into picture because of short circuit inductor. So only resistance you have 2. So 50 by 2, that is 25 ampere. And I of 0 plus is nothing but I of 0 minus, which is 25 ampere. Okay, that is step 1. Step 2, we have to find tau. So for that, we know L directly, that is 3, but R equivalent we have to find. So what is R equivalent? This is after t greater than equal to 0. So when after t equal to 0, that time we have to find the tau, time constant. Okay, so how to find that one? That time, what do you mean by R equivalent? R equivalent is the equivalent resistance seen by the inductor. Okay, so how to do that? So here you have 50 volt, 50 volt. To find the equivalent resistance, you have to deactivate the independent voltage source. So if you deactivate these two, this 50 volt and this 50 volt, then you have a short circuit here, and you have 2 ohm and 6 ohm, and here you have inductor, and this is nothing but R equivalent. This is 3 Henry. So R equivalent is 2 parallel 6. 2 parallel 6, that is 2 6 that 12 by 8, that is 1.5 ohm. So our tau will be L by R equivalent. L is 3, R equivalent is 1.5, that is 2 second. Okay. Step 3. Step 3, we will write the response I of t. I of t will have two components. One is natural response, another one is force response, In of t and If of t. Since it is driven RL circuit, we will have natural response also, force response also. And how to write this In? So we will first consider In. In form is A into e power minus t by tau. Tau is already calculated, it is 2. Okay, and A we have to calculate from the initial condition. First we will write If also. What is If? If is, If we can also call it is I infinity. So if the circuit is kept as it is for a longer period of time, what is the current flowing through in the inductor? So what happens? For that we have to see the circuit t greater than 0, that is this circuit we have to see. So here if 100 volt is kept for long period of time, what happens? Again this act like a short circuit inductor. So this 6 ohm will not come into picture. So because this short circuit is in parallel with 6 ohm, that is nothing but a short circuit. So you have 100 volt and 2 ohm resistor, and you have a short circuit inductor. So what is the current flowing through this? That will be 100 divided by 2. So 100 divided by 2. If is total voltage 100, 2 ohm resistor, so that is nothing but 50 ampere. So now what we have to do is, our I of t is A into e power minus t by 2 plus 50. Now only remaining is we have to find this constant A. Okay, step 4. Step 4. Step 4 is we have to find A. For that we can use this condition. I of 0 plus we had already calculated. What is that I of 0 plus? In the first step we calculated is 25. So we will use that one. I of 0 plus is equal to 25. That is equal to A into e power, you have substitute t equal to 0. That is, this will be 0 plus 50. So A will have value minus 25. So if you substitute in the main expression, that is I of t is equal to, I of t is equal to, we can have like this, 25 for t less than 0 initial value, that is I of 0. Before that I of 0 minus is equal to I of 0 plus. So at t less than 0 the current is 25, but after this one t is greater than or equal to 0, so that time you have to use that expression I of t equal to In plus If. What is the natural response? Natural response is minus 25, that is A e power minus t by 2 plus force response. Force response is 50. So this is the solution for the above problem. Minus 25 e power minus t by 2, it is minus, plus 50 when t is greater than or equal to 0. Okay, that's it.